Alright everyone, now we're going to do the Lab 1 hardware, where Lab 1 is the diode characteristics and rectifier circuits. So the first part of the hardware is to construct the circuit here. The 330 ohm resistor with the diode, and we're going to do some DC measurements of the current and the voltage across the diode in order to extrapolate N and IS from the data. So first we need the 330 ohm resistor, which is this one right here. Looks like, let me see if the camera will focus. Orange brown is what it looks like. I happen to have a really cheap, simple multimeter here just to verify, but it is indeed about 330 ohms. Okay. And the other resistor you need is brown, black, red, which is a standard 1K resistor. We'll need that later. In addition to the diode and 10 microfarad capacitor you'll need later. So I'm going to turn off my meter here. Done with that now. I kind of got some jerry-rigged setup thing here so we can record as I construct the circuit here, as long as I can focus. There we go. So I'm going to start by putting the diode in the circuit. There's a little line on the diode piece that corresponds to the line in the circuit diagram. So I'm going to put this guy from in column H in between rows 1, 2, 3 and 10. You can put it wherever you want, but those unfamiliar with the breadboard can kind of follow along. And we need the 330 ohm resistor. It needs to be in that same row to make the connection, and then from over here I'm going to cross over to C3. That guy goes C3 to G3. And that's it for our circuit. Pretty simple, right? So now we have to set up our analog discovery module. So I'm a bit unfamiliar with this, but we'll figure it out. First thing we need is a DC voltage source. So V plus corresponds to the red wire. And I'll try to keep these things constant. I have like a female end there, so I have a red wire here I can use. I'll connect that, and that's got to go into row 3, so I put that at A3. Next we need ground, so I'll grab a black wire, and black wire coming out of the analog discovery, that's got to go to row 10 on the right side, so I put that in J10. And so that's going to supply our DC voltage that we're going to sweep. The next thing we need is the multimeter. So I'll need another black wire, and the multimeter is these orange ones here, actually. So I'm going to get 2 orange wires. One has a stripe, one is solid. So I'm just gonna put this across the diode for now. So J3, and put the bottom, if I can find it, 1 minus. That's gonna go down to F10. So I'm looking at the voltage across the diode here. Okay, so that's it for hardware setup for now. Let's go back over here, and I have waveforms installed on my computer. Looks like communication failed. Okay. reconnect. It's been acting kind of funny. Alright. Let's see. How do we reconnect? Analog discovery 2. Is that it? No, that's not it. Just gonna restart it, I guess. Communication with the device failed. Okay, seems to be working now. We'll see how long it lasts. So, first thing we need to do is set up the DC supplies. We want to have, we don't really care about the negative supply, we just want the positive supply. And we're gonna sweep it. But let's set it to 1 volt for now, I guess. And you can turn off the second one. Master enable on. Okay. And let's go back here and let's turn on the voltmeter. And click run. And it seems reasonable. 1 volt input gives me 578 millivolts across the diode. So if I go to our Excel spreadsheet here, and I'll zoom in a bit, it's probably hard to see. Okay, so diode voltage. Actually, I specify which V supplies to use. So 1 volt is the first one. So V diode is 0.578. V resistor, that's the voltage across the resistor, is going to be the difference of these two. Because whatever isn't dropped across the diode has to be dropped across the resistor. That's the way loop analysis works. So this column is going to be equal to this column minus this column here. R, if you can't measure it because you don't have a multimeter, then you can just assume it's 330. I think mine was pretty close, so I'll just say that it is. And then you can calculate the current based on voltage across the resistor divided by the resistance. And it says in milliamps, so we have to multiply by 1,000 actually. Alright. It's 1.278 milliamps. Alright, so we're just going to step down. If I go back to this guy here, gonna increase this to 1.5 volts, 2.5 volts, you know, all these options. The last point is 5 volts, so I'll try that one. And it looks like V diode jumped up to 689 millivolts. 689, and we can just, oops, sorry, we can drag these columns down to autofill. This is always 330, I don't know why. Okay. And you can ignore these points obviously because I don't have data here yet. But I diode is 13 milliamps in those cases. So let's try 3 volts really quick, and then I'll let everyone else fill in the rest. 3 volts is 659. And there you go. So I'm going to delete these other points for me. Okay, and you guys guys can fill in all the rest of the data here. But this will automatically generate a plot here, and I've fit an exponential curve to this so that you can figure out what IS and NR based on our pre-lab analysis. And for my 3 data points, it looks like it's a pretty good fit, but it might get a little worse as you add some more points. You'll have to see. Alright, so that's the first part. Not too bad. Once you have N and IS, just fill them in here. And you want to get a picture of the hardware setup. So just with your cell phone, just grab a picture and paste the picture here. Basically just showing that. Okay, so the next circuit is the half-wave rectifier. So we have to change things around a little bit here. I'm going to turn off my power supply, stop my multimeter. Don't really need it anymore. Don't need the power supply at all for the next part actually. So I'm just going to close out of both of these. We're going to use the function generator next. So let's go back to our circuit. Okay, and I'm going to start deconstructing some things because I have to rearrange some components. So this time we need the 1K resistor. I'm going to get rid of the other one, the 330. And I'm going to stick with row 3, but the diode's going to go here. For this circuit, the diode and resistor basically swap places. So we got the diode, and we have the resistor going from row 3 to row 10 now. And of course, direction of the diode is important. Next, we're going to need the capacitor. Not yet, but I'll have it here just so we can quickly incorporate it later. Alright, so now we want to use the waveform generator, which is the yellow output of the analog discovery. We'll see if analog discovery crashes on me again. So function generator is going to go into row 3 of the diode. That's where we want our sine wave to go. Ground is going to go to row 10. I'm going to put them over here because I know I got to put a cap over there later. And we want to measure across the resistor. So we can use the channel 1 again, I believe. So solid is positive. So we'll put that in row 3. Top. Actually, we want to show input and output. So I'm going to put this on the signal, which is row 3 on the left, to ground. And blue is channel 2. So let me get a couple blue wires. And we'll connect that across the output. So channel 1's the input, channel 2 will be the output. That's connected to ground. And that should be it for that. Got our input signal, circuit, and our scope probes. So let's go back over here. Looks like I'm still connected. So we will do the wave gen. And this says to do 60 Hertz, I believe. So you might have to dial that in directly. 5-volt amplitude? Is that what it says? Let's have a look. 10 volt peak to peak at 60 hertz. So let's go back here. 5 volt amplitude will be 10 volts peak to peak. 50% symmetry. Looks good. So let's run that. Now let's go back to here and turn on our scope. And I guess we have to run it. And I'm zoomed in a bit too far, but it looks like it's working. So let's change our base time here so that we zoom out a bit. And we also have to adjust our scale here as well, so that we can see the signal. Kind of got to be a little smart with this and know what you're going to be looking at so you can zoom in appropriately. Okay, so yellow is our input signal. Looks like it's 5 volts peak to peak, or 10 volts peak to peak with an amplitude of 5, swings +5 to -5, and the output looks like a half-wave rectifier, so it looks good. So with this, we can stop it if we'd like, and there should be a way to export the data here if we'd like. File, maybe export. What does this do? Yeah, this copies all of our data to the clipboard, I guess, and we can save it. So it has the time point, it has the voltage on channel 1 and channel 2 at each of those steps. So for example, if we look at the peak values, so when channel 1 is +5, it looks like it's about right here. Oh, getting close. Somewhere around here. Looks like the output is 4.339. So the difference of those two gives us our peak offset. And with all this data, you could reconstruct this in Excel if you want. And you could also take any 2 data points on here, decently spaced apart, and you could calculate RD and VDO as well, which is what is going to be asked for in the lab here. So I just said how to get peak offset, RD, and VDO. You can also use this data to find the conduction time as well. So you can copy this to clipboard, or you can save it. I'm guessing it's going to prompt me for it's going to ask me to save a CSV file, which you can open in Excel and play around with. Okay. So that's that. You should be able to get all those measurements here. You want to get another picture of your hardware setup, which should look something like that, as I showed earlier. And then you want to get a picture of your scope. Or if you import this into Excel and you want to plot it that way, you can do that as well. You don't have to show the waveform generator down here, only if you'd like. I would prefer if you actually just get the scope image for this picture. It'll just look nicer for your report. Alright, so the next part is adding a capacitor, which kind of acts as a filter. So it's a pretty easy addition. Go back here, add our cap, and we will put from row 3 to row 10 in column J. And that's it. So I never turned off the function generator. I probably should have though. But if I run this again, you'll see it looks like a ripple circuit now. And again, you want to get a picture of your hardware setup, picture of your oscilloscope image, and This time we just need to measure V ripple, which you can just get from exporting the data and measuring the peak and the min of channel 2 in my case. And that's it. Once you have all those things, you can submit this file with all of your pictures and data, and as long as it looks reasonable, then you'll be all set for the lab.